Okay. Good morning, good afternoon, or good night, or whatever, wherever you are. Everyone, welcome to this video session. And in this video session, I want to give you a demonstration of how machine learning can be used in cybersecurity. In case of cybersecurity, using cybersecurity data. As you all know, cybersecurity is a very important uh, issue in these days, and almost uh, every sector of our life, every uh, angle or every inch of our life is now digital. uh, E-governance is there, medical facility, uh, different types of schooling, everything is digital these days. And there are some people who want to take advantage of this situation, and they steal data and harm others in various ways. And all over the world, the cybersecurity attacks has increased um, multiple times in the last few years. So, how machine learning can help? In using machine learning, we can automate the identification of cybersecurity incidents as malicious or benign. That is one. There are other applications also, and I plan to host uh, some other videos in this series that deals with cybersecurity and machine learning. This is the first one of them. So, without further delay, let us start. Let me share my screen. Uh, can you see my screen now? Okay. Okay. So let me start. This is the data that I have. This data set I have downloaded from Kaggle, and it is a data set about server requests. Okay. So these are the incidents. So every request that came on that server has been recorded as an incident, and uh, those incidents can either be malicious or benign. Okay, so if it is benign, then it is uh, labeled as one. If it is malicious, then it is labeled as zero. Our task will be to process this data and create a model that will automatically tell us whether a request is benign or malicious. Okay, so let's start. First, I import the rudimentary packages. Okay, then I'm going to load the dataset. So let me give the file path. This file is in the same directory as the dataset. So just giving the file name will do. So server underscore hack underscore data dot csv. CSV. Let's see the how it looks. So df.head. First 5 rows of the dataset. Uh, let's take a sample. I just want to see randomly chosen 5 rows. Okay, so that's how it looks. Okay. Uh, what I want to do, I want to get rid of these two columns, incident ID and date. Why? So, because incident ID identifies a particular incident and it has nothing to do with the type of uh, request. Also, this date column is not going to help us much because those who are doing something bad, the hackers, what do they do? They deliberately uh, hide their intentions by making their attacks random as possible, so that no pattern can be found. Honestly speaking, if you know that some bad guy is going to attack your system at 7 p.m. every night, then you are going to shut down your system and disconnect it from any type of power source and internet, right? So they mask their attacks, uh, and the first thing that they do, they make it random. They make it look random. So incident ID and date, these two columns we're going to get rid of. So let's do that. Incident ID, another one is date, and axis, we want to delete columns. Done. Now if I check about the features of this dataset, uh, you can see that incident ID and date is no longer there. So these are the features. The people who made this dataset has made the features pre-processed in some way. So uh, it is not possible for me to, for or anyone to understand what these features means exactly. But the dataset is authentic. That's for sure. So there are 15 features and one target column, malicious offense. And as you can see, there are 23,856 entries. Mm, all of them except this one, it has fewer columns, fewer not null values. So this column contains null values. So we are going to remove those null values from this data set. Why remove? Uh, I can impute also. So first, let us check how many nulls are there. Tf dot is in a sum. Okay, so we have 182 null values uh, for x underscore 12 feature. Okay, so 182 rows. I can impute the data by replacing the null values using mean value or something like that. But I think it is going to be helpful if I just delete those. So what is the percentage? It's very less, 0.007. It's not even 1%. Okay, so we can safely delete that data. So tf equals to tf dot drop na. Okay, dropped. Again, check whether it has been dropped. Yes, it has been dropped. Another thing, is that my goal in this video is not to show you exploratory data analysis, visualization, all sorts of things. Those things should be done and has to be done in for a real life case scenario. But uh, here, my uh, goal is to apply machine learning to this data set, and I'm just going to do some rudimentary pre-processing, not more than that. But uh, in real time or serious case, before machine learning, those steps has to be fulfilled. Okay. Now, next thing that we are going to do, we are going to see how the class is distributed. Okay. Means how the target variable is distributed. Is it uniform? Huge imbalance as expected. This imbalance is very prevalent in case of cybersecurity. Why? Because malicious attacks, cyber attacks are, if you look at the ratio, they're very small uh, compared to the non-malicious or benign requests. As an example, just take the example of credit card transaction. How many credit card transactions are happening every minute? Millions, right? And how many of them are malicious? One, two, 10, 100 maybe, not more than that. If it is more than that, then it will be a major security incident and those systems will be shut down, those servers will be shut down. So the hackers pace their attacks very well, and as a result, what happens is that in the data set there is huge imbalance in classes. Now what we can do, we can downsample the benign class into 1068, or we can upsample. Now personally, there are some other ways of treating imbalanced data set, and my choice will be to upsample this malicious class into this many classes and this many samples. And that's the most uh, effective, in my viewpoint, way of dealing with imbalanced classes. So let's do that. But before we do that, we need to separate the malicious and non-malicious rows. So for that, df malicious offense equals to 0. And I want to select all those, and let's say mal for malicious. Okay. And benign, so ben, same thing. Oh no, it's going to be 1. Okay. Now let's check the shape. Mal dot shape and benign dot shape. Okay, we have separated. Now I want to resample. I want to upsample. Okay, so for that, scalar dot utils port resum. Okay, okay. Now let's resample. Resample the malign or malware uh, malicious requests, and number of samples n underscore samples that we want to do. We want to make the count will be this one. So benign dot shape dot 0. So benign dot shape under index 0. Okay. And when we resample, it's going to give us samples, I guess. Yes. So it's going to give us back a data frame that has those that many rows. Okay. So let's store it somewhere. Let's say M2. Now we want to merge benign and M2 to make our modified data set. So let's say df2 pd.concat benign and M2 axis equals to index. All right. And df2 dot info. Okay, so we have the pumped up data set, as you may call 45,212 entries there, and there is no null value. There is no null value. So we have our data set now. Next, we want to separate our x and y values. So let's say x equals to df2 dot drop malicious offense axis equals to columns, because I want to remove a column, and rest of them will be the x values, and the y value will be df2, and select this malicious offense. Done. Now let us check how the features, the basic statistics of features. Okay, so x dot describe. Okay, as you can see, the range of values are different for different features. So x underscore 1 is 0.04. This is the mean of x underscore 1. For x underscore 2, it is 25.66. For x underscore 3, it is again 25. For x underscore 11, it is 185. So also the standard deviation values are different. So we need to rescale. We need to rescale. Whenever this thing happens, we need to rescale. But before we use rescaling, okay, we need to split the data. So let me import a few more classes from scikit-learn library. Scalar dot model selection, train test split, okay. So the split, and then scale the value, so that they all come under the same scale. Everyone is going to have 0 mean and 1 as standard deviation. Okay, so first let us split the value. Train test split x and y, and it's going to return a 4-element tuple value, which I'm going to store in x training, x testing, y training, and y testing. Okay. Uh, what should be the split ratio? Let's say test size equals to 15. Okay, I want to 0.15. I want to reserve 15% of the data set for test purposes and 85% for training purposes. Done. Now I would like to create a scalar, standard scalar object, and say scalar dot fit transform xtr and store it in a data frame. Okay, so pd dot data frame, because I want to check those statistics one more time. I could have done that using the raw uh, array that is returned by fit transform is going to give me an numpy array, but I just want to make it a little bit more aesthetically pleasing. Data frame. So that's going to be the data of the data frame, and columns equals to xtr dot columns. Okay, and I want to store this in xtr1. Okay, and same thing, xts1 will be equals to pd dot data frame scalar dot, here I'm just going to use transform xts columns will be equals to xts dot columns. Okay, so that will do. Now let's see xtr1 dot describe. Okay. Okay. So mean values have become zeros. This is it may not look like zero, but it is zero, because 3.3 etc after the it will come after uh, 17 16 zeros after decimal. Okay, because e to the power minus 17. Same goes for the other values also. E to the power minus 17, e to the power minus 17, e to the power minus 16, etc. Standard deviation has become 1, as you can see. Okay. So let's check out the XTS value. XTS dot describe XTS1 dot describe mean is 0. Uh, it is a little bit lesser, closer to 0 than the XTR1, because we didn't let this scalar object to know about the test data. We didn't fit it on the whole data. If we did, then it would have been a case of data leak. So we didn't do that. But anyway, it has become 1, the standard deviation 0.991. So the results are not that perfect in case of training data, but it's okay, more than okay in fact. Next, what we want to do, we want to create a model, machine learning model, and for that I'm just going to use from scalar dot ensemble import random forest classifier. Okay. I want to compare two models. So let's import another one, scalar dot neighbors, import k neighbors classifier. Okay, done. Now I'd like to create two objects of those two classes, train them using the training data, and then ask them to predict um, the test data, and then compare the predictions with the real test data target values. So that I want to do. So first is going to be the k nearest neighbors. Okay, let's say KNN model. So that's the variable that is going to store the reference of the object of this class, k neighbors classifier. Let's create this k neighbors classifier. And I'm not changing any default settings of the parameters. See, there are a number of neighbors is set to 5, weights are uniform, algorithm is auto, leaf size 30. This is the distance metric parameter, p equals to 2. So although the metric is Minkowski, this p equals to 2 makes it Euclidean distance. So a lot of things, a lot of parameters, hyperparameters can be changed or tweaked with uh, here. But again, my goal is to just show you the how a data set that is related to cybersecurity field can be used with can be given input to a machine learning algorithm, and uh, is going to take is going to work anyway. Okay, so I'm not going to change those hyperparameter values, but in case of real analysis, this will be done. This has to be done. Okay. Even if we are using advanced techniques like deep learning and all, uh, for comparative study, every known or important algorithms has to be applied to the dataset. Okay, so we're going to build that model, and so build that model. The model has been built, and then we're going to say knn underscore model dot fit, and we're going to supply xtr xtr1 and yts, sorry, ytr. Okay, so we're going to fit it. Yes, it has been fit. And then we're going to say y predicted value by the knn model. We're going to ask it to predict. So knn underscore model dot predict. What it is going to predict? XTS1. Okay. So we have the prediction. We have the prediction. Now we want to compare those two the prediction values. Okay. Now here I want to point out one more thing, and that is that this very simple simple approach of fitting and prediction in real life scenario, this is also going to change. In that case, we are going to uh, use the perhaps use the k-neighbors classifier class from the scikit-learn package, but we are going to customize. We are going to customize according to the data set we have. So we may create a new class, or we may create a new function or something like that. So the code is not going to be this much easy, but for all practical purposes, for just seeing how it is working, or whether it is working or not, in the first phase, this has to be this simple, because this first phase, whether it is working or not, uh, will be done in a very extensive manner, and so it should be fast. It has to be fast. Okay. It may not be perfect, but it has to be fast, and that is the entire goal of this video. Okay. Now I want to compare those two values, yprknn and yts value. So let me import the metrics. So from sklearn, import metrics. Okay. I just want to print one thing, and that is classification report. I just want a rough idea how it is working. So let's print metrics dot classification report, and here I'm going to supply the actual test value of the target variable yts, and the predicted value of the target variable by the knn classifier. So let's see. Okay, so it's giving me 98% accuracy overall. Precision and recall are somewhat, it's okay. F1 score is okay, so it is 98%. Uh, there is a tally, excuse me, there is a tally between precision and recall and accuracy value, which is needed, which is needed. Okay, so these values says that we can use KNN algorithm to classify the cybersecurity data, the server hack data. Okay, um, can we improve it? Absolutely, absolutely. But for that, we need to do hyperparameter tuning, um, modify the algorithm in some way. Uh, but again, that is not my goal here today. Okay. So let's move on to the second one, random forest classifier class. So first I want to create a model or object of that class, say random forest classifier RFC, random forest classifier. Again, this has many uh, hyperparameters, like number of trees that will be created, number of decision trees that will be created. Here it is by default 100. I can increase it, decrease it. Criterion is Guinea. I can make it information gain, max depth, mean sample split, loads of hyperparameter that can be tweaked with and experimented with. I'm not going to change any one of them. I'm just going to leave them by in their default of that in the default value settings, and just apply them, apply this model as fast as possible. Okay, so now I'm going to do model RFC dot fit. Again, I'm going to supply xtr1, x training data, and ytr, and then we're going to say predict. Okay, so ypr by the random forest classifier, and I'm going to say model underscore RFC dot predict the x test value xts. Okay, it will take a little bit more time, as you can see, because random forest classifier is applying that whole data set into 100 different decision trees and then summarizing the result into one result. So it took a little bit time. Now I'm going to print the classification report. So print metrics dot classification report y test value and y predicted value by RFC. Uh, See, it's giving me the perfect result. Everything is one, means 100% accuracy is there, 100% precision is there, 100% recall is there. So everything is perfect, and it should not. Why? Because in real life scenario, this kind achieving this kind of accuracy and precision and recall and getting this kind of semblance balance among their values is very very rare. So we can draw two conclusions: either this data set is synthetic or this data set is has been tweaked in a very very good way so that this kind of results can be obtained. And most probably the second decision is true, second option, second possibility is true, because if we are feeding good data to the model, then they are going to give us back good predictions. Okay, but the point is that the whole point is that whole point of this video is that we can use machine learning algorithm uh, in cyber security. That is not a new thing, but again, it has proved itself. So we can use machine learning in cybersecurity for different types of uh, predictions and other tasks. I'll try to bring more videos of this kind that is related to machine learning and cybersecurity in future also. So let's see how it goes. So thank you all, and see you in the next video.